Mr. Bush's mom. Just get your math done. He's gonna show you some stuff.
Okay, well, let's, this is 2018, number 2. Shouldn't be too bad. We've got a function. We got the velocity for the function. It's a closed interval from 0 to 3.5. The starting position when the position is -5 when time is 0. So it's moving along the x-axis. So the name of the function is x of t, and if you take the derivative of the function x prime of t, you get v of t. Okay, so anyway, find the acceleration when time is 3. In this sense, it's number 2 is a calculator problem. So the acceleration, the only work you have to show is v prime of t. V prime of 3. Is then the answer. So let's see if we can figure that out. Y equals, I had a fraction. 10 sine of 0.4 t squared. And t squared minus t plus 3. Let's see if that's right. I'm really good at forgetting stuff. All right. And we want to find the derivative in terms of x for y1 and x equals 3. It's negative 2.1182. 2.1182. It's negative. Let's not forget the negative sign. Okay. Find the position of the particle at time equals 3. We've done problems like that. Now I'd like to come up with a position function and then use it to find the position. So the position function, we're going to define this as an integral, and we know that at time equals 0, the position is -5. So this integral has to start at 0, ends at t, and since the position is -5 at time equals 0, we want the value of the integral to be 0 when time is 0, and then when you add the -5, you actually get the -5. So the position is the integral of v of t dt plus -5. So x of 3 is -5 plus the integral from 0 to 3. Oh, I gotta change those t's to x's. It is definitely my favorite. Oh, I don't want to use x's. I want to use something else. Like, it could be anything. W's. Okay. So from 0 to 3, a v of w dw, which is, let's find out what number that is. -5 plus the integral 0 to 3. I should show you here. y1 dx. -7, -1.7602. see, I'm going to put the answer down there. Okay, see the answer? Make sure the name of the function, the variable in the function, and this variable in the integrand of the integral are 3 different letters. Okay, so for t, we want to evaluate that and interpret the meaning of each. So let's evaluate this. And hopefully you know that this is the displacement and this is the total distance traveled over the time interval from time equals 0 to time equals 3.5. That's that many units. So actually I'm going to use this. I should get it. And that is 2.8439. 2.8439. And then, I don't know if I can. That should get us the total distance traveled. And that's taking a little longer. 3.7371. Okay, so your particle's displacement from time equals 0 to time equals 3.5 is 2.8439. The particle traveled a total distance of 3.7371 units from time equals 0 to time equals 3.5. Okay, so there are the two answers. And D, a second particle moves along the x-axis with a position. So there's a new function for the position. Same time interval. Yep. Same time interval. And what is the time that the two particles have the same velocity? So the velocity of the first one, v of t, has to equal the velocity of the second one. That would be x sub 2 prime of t. We're going to set those equal and solve for them. I'm going to change my window from 0 to 3.5. I've already got the velocity of the first one. So let's do the velocity of the second one, which is quick and easy, 2x minus 1. 2. That's not a 2. And if we graph these are the velocities. So where do they have the same velocity? It's like right around there, 1 point something. So when you're using your calculator on these calculator problems, you just need an equation and then you need the answer. So I'm going to find the intersection. Ooh, that's pretty close. 1.5705. two particles. It's LE, isn't it? Have the same velocity at time equals 1.5705. And that's it. I have time, so I'm going to check out the scoring guidelines. So for A, the acceleration of the particle at time equals 3 is negative 2.118. Probably should box it, right? B has 3 parts. 1 point for integrating from 0 to 3. 1 point using the initial condition, -5, and 1 point for the answer. Okay. For C, there are 2 answers. So the 2 answers are, you can't see C. I wonder if you can see the other ones. That and that. And interpreting them. So displacement for the first one and total distance for the second one. And then for D, which I didn't label, is sets them equal and has the answer, right? Any questions? Setting them equal is worth 1 point and getting the answer is the other one. Okay. When you have a calculator, you don't need to even write the whole functions out. If they label the function as being something, then you can use that. And if they don't, can't imagine a situation where it's not. But you can label it. You can name a function. I guess I would always have a name. So anyway, that's what I got for you. Have a great day.